In today's continued expansion of this telephone central office project, I'm adding this DTMF decoder board project I made a few months ago, and this uses the MT8870 DTMF decoder, so it hooks up to the tip and ring on the phone line. In this case, I have it hooked up here on the breadboard, and I'm using this other PCB that basically has header pins and an RJ phone jack. Then I just have a Y adapter plugging into that original phone line SLIC module. So now the phone itself is plugged into the module as usual, but also I'm tapping in and then listening for DTMF tones here. And this board is powered with 5 volts, and it has a delayed steering output signal to tell us when there's been a tone detected. And there's 4 Q data outputs that can be decoded to see exactly which phone key was pressed. The circuit on that DTMF decoder looks something like this. When we extract the audio signal out of the phone line, we feed it into the chip, and when we see the delayed steering signal go high, it means we can read these 4 Q signals and see what button is pressed. And as long as this incoming audio contains a valid DTMF button press, this delayed steering is going to stay high, and then it drops when the tone disappears. So the goal is, when we get the delayed steering signal going high, we want to get around to reading the data as soon as we can, and then ignore this data until the next time delayed steering goes high. So I have it set up to detect 0 through 9, as well as star and pound. There's a few other tones, but I'm ignoring those for the purposes of a regular phone system. And so now in the sketch, I added another file. This one's an INO file. And if there's other INO files, I think the way it works is those get appended to this when compiling, so it's the same as if you had one long INO file. So I'm taking advantage of that to just keep things clean. So miscellaneous functions, I'm just offloading things to keep the main INO organized. So I'm doing things like initializing various parts of the system, setting up inputs and outputs on the GPIO expander, and out in the main file, I'm doing whatever's necessary to get set up and run the main loop and handle my interrupt, where all I do is set a flag saying there has been an interrupt, and the main state machine. Then there's nothing else left in the main sketch, just so it doesn't get bogged down. So to do the demo, I'm going to reset the module. This time I set the flag so that it's back to North America tones, and I'll just do a quick run through again, generating those tones in the speaker. And in my debug printout for the system flags, I've added the DTMF stuff just so I can see if I'm in the right mode while I'm trying to figure out if I got the sketch right. So I can tell if I'm trying to ring the phone or not, whether the phone is on hook or not, whether currently a DTMF key press has been detected, and then there's this other trigger DTMF flag, which I'll explain after we go through the demos. So now, if I pick up the phone again, I should get a dial tone. But now I'm going to test if I can detect DTMF. So when I answer the phone, just like any normal phone call being made, as soon as I press a button, I want the dial tone to stop, and then I want to detect further DTMF presses in the system so I can tell if I'm making a phone call. So I pressed 1 and the dial tone went away. And now, because I pressed a key, DTMF flag went from none to tone because I detected a tone. And I went from not triggered to triggered, which we'll look at. So there may be a glitch here, like I press a key and I may see multiple printouts here, but that's okay for where I'm at right now. So I'll press them all. 2, 3, Okay, well this one went cleaner. I was getting a messier response, like I might press 8 and see a bunch of 8s, but that could be anything from the wiring just triggering IRQs to go in and read data more than once, or even just bugs in how I'm printing this out. So that's okay. I'll just hang this up now. And we're back to not being triggered on DTMF events. There's no tones detected. We're now on hook and we're still not ringing, and we're waiting for more commands. So to get the DTMF decoder integrated on my MT8870 GPIO expander, I've already got 3 of those pins dedicated to that slick phone line interface module. And now the remaining 5 GPIO go to the 4 DTMF data and the delayed steering data valid indicator for this MT8870. And in my system flag byte, I've added these 2 flags regarding DTMF data detection. So I'll explain how I ended up with 2 flag variables here needed to be able to track the button presses. So I drew this diagram, and these represent the 2 flags in the system, D and T, for DTMF data available on those 4 Q pins, and T for a DTMF event has been triggered, which basically means this delayed steering has gone high, and it is time to read data. So with the MT8870, it will generate an IRQ back to the ESP8266 on rising or falling edges. And I do have the other slick module IRQ to tell me if I'm on or off hook. So even if that occurs, I'm going to need to differentiate, is it time to read DTMF signals? So first, I only want to pay attention to reading DTMF on the rising edge of delayed steering. And that's when the Q pins have valid data to get to ASAP. So when things are idle, my 2 system flags are 0, so there's no valid DTMF data, and I have not triggered that there is any sort of event. As soon as I get an IRQ, I'll go read this delayed steering pin, and if it is high, it means that's what generated this IRQ, and it's the rising edge of it because we read it and it's high instead of getting an IRQ here and then reading it and seeing it's low. So at this point, I'll set both of these flags in the system. So there is DTMF data to go read, and we just triggered a DTMF event. So at some point in the sketch within the state machine, when there's an opportunity, I'll go and read the 4 Q pins to see what the DTMF key press was. And at this point, I've now handled reading the data. So I set data flag to 0, but I'm still in this triggered event because delayed steering is still high, which means physically somebody is still holding a button down and audio is still present containing DTMF signals. So I want to say that I'm still triggered, because if there's some reason I would be reading these 4 data pins again during this single key press, that's what this signal really means. Somebody is holding down a key. If I come in and read this more than once, I might accidentally detect somebody pressed 3 and 3 again and 3 again. So eventually, when I get another IRQ and I read this delayed steering and I see it's finally low, then I still have data being low because I've already handled reading it. And now the trigger event is over, so that goes to 0. And now I know the next time I do get an IRQ, I can tell from both of these flags being low and from reading this being high, this means we just transitioned into a new event. So I trigger it and read it and ignore it again until this goes low. So that's what's going to be happening in this sketch. So if there has been an IRQ detected in the main loop, this is where I read the delayed steering pin to see if it's high, and if so, I check my system flags to figure out where am I in this entire DTMF event, and I will set or clear flags as needed. And down in the state machine, in this certain state where I'm testing if the phone is off hook and I was generating a dial tone, this is where I'm checking if there's DTMF data to be handled. Go in and get the key press, stop generating the dial tone, and print the key press on the serial monitor. So those functions like read DTMF are over in the other INO file to keep it clean, And if I call this function to read the DTMF data, and for some reason I shouldn't be in here because the system flag says there's no data to be read, we just get out. Otherwise, we read in those 4 Q pins, and based on what they are, we can tell which DTMF button has been pressed. And now that we've decoded it, we clear the flag saying there's no more DTMF data at this time, the next time we want to process it. And the function itself returns whatever character we've decoded. So wherever I call this read DTMF function from, it will now get the character and do what it needs to do. So this system is coming along well, although it's getting a little bit congested on the breadboard. We have the ESP8266, PCF8574 GPIO expander, the SLIC module that handles the main phone interface, RJ connector breakout board with the Y adapter, and the DTMF decoder, also going back to this GPIO expander. So I'm getting near the point where it's time to get this stuff on a dedicated PCB. And of course, there's more software to write, so I'll continue working on this.